Alright, so in this lecture, I'm going to talk about object-oriented programming, which is the chapter 2 in our book. So the topics are why we do object-oriented programming, inheritance, which are classes, and interfaces, and abstract classes. We might not talk about exceptions and casting and those things because I think those are too detailed, and you will see them in your practice. Okay, so let's get started. I will follow the slides and making up examples as we go. So for example, so the goal of doing all these classes is the idea behind object-oriented programming is that we want to perceive the world as if the world is composite of objects. So instead of thinking about numbers, about booleans, structures, say maps, graphs at different things, let's all perceive them as under a super class called object. Let's say everything is an object. Okay. Let's say no matter it's soul, it's love, everything is an object. Okay. And by doing that, we can begin to draw a graph, which is a tree of hierarchy. We can say, oh, certain object is a superclass of other object. Okay, certain class is a superclass of other class, meaning that certain class includes the concept of the subclasses. Okay, and having class are not enough. Having class is more like an abstract notation. For example, the class of cars. Okay, let's make one class for cars, let's say. So let's say we have a class called car. Okay, and we will make this an abstract class because it's an abstract concept. Right? So what should an abstract class do? Right? Examples are a car can turn on the engine. Okay, so let's say turn on engine. Okay, and I intentionally, let's say, has a boolean that says if its engine is on. Okay, and we can keep it private so that the outside doesn't access it. And in our turn on engine, we can say engine on is now true. And similarly, we can have a turn off engine, where we can say, okay, engine on is now false. Sorry, coding too much Python. All right, so this is our first abstract class. Now, it's okay if I just make this a class as well, it doesn't matter. But having an abstract class gives it some special ability. For example, in an abstract class, you can define an abstract method. Let's say go. A car can go. An abstract method means that, so you can see the error here. And right now I'm building a function with a body in my parentheses, right? The body right now is empty, but there is a body. But having a modifier abstract, I'm saying that this method is an abstract method. I haven't thought about how a car is going to go yet. Okay, it's still an abstract idea. For example, a bird can fly, but I don't know how a bird flies yet. Okay, I'm not going to build a function body there. So I make an abstract. And by doing that, this becomes an abstract method. And abstract method is only allowed in an abstract class. So for example, if I take away this abstract modifier for a class, meaning that this car is a solid class, like I got an error here saying that Okay, so by having this class now no longer abstract, the methods inside the class can no longer be abstract. Okay, so if this class is not abstract, I have to take away the abstract keyword, and now I have to fill the body, and this would be okay. Okay, so let's revert to our abstract class. Okay, so we have our car like this, right? And let's say the car also has a make and a model and a year. Okay, so there will be an integer here, and all of them will be private. All right. Here's the thing. Using Eclipse, you can do, if you, for example, right now this make is private, right? It's private, that means it cannot be accessed by outside world. And it doesn't make much sense because when you define a variable, when you define a value, you want to use it somehow. You want to either set it or get it. Okay, so you can do this by doing right click, refactor, and then there will be, that's right, source here. So you can do generate getters and setters. And you can check the variables that you want to make getters and setters. For example, engine on here, I define my on turn on engine, turn off engine. I don't want to getters and setters here. By the way, getters is a different name of accessor, and setter is a different name for modifier, right? So we want that for our model and for our year. So by checking those boxes, when I click on generate, it's going to create this method for me, and it's going to create an under public modifier. Okay, right, and you can rearrange the locations if you want to. So let me put them under year. Okay, so this is my abstract class. Now, having an abstract class, so let me do that in the demo here. Let's say we are under the same package, right? Demo02 should be able to access car, right? Should be able to access car. So let's say we are going to create a car instance, right? Car instance 1. Okay, so here the car class is available, but I don't think I can do this yet because the type of car is abstract. You cannot instantiate an abstract class. Okay, so what do we do with abstract class? Like almost always, when you have an abstract class, you will have subclass that inherit the abstract class and make it non-abstract. Okay, so in terms of car, let's say we will have a another class called let's say gasoline car. Okay, and the superclass of that gasoline car will be our car. And you can do the browser here. You can find the car. Okay. So let me comment out this first. So you can see that by generating a new class, this class extends our car class. Okay. And notice that I cannot do abstract here. Can I? Yeah, I can still do abstract here. Okay, that's amazing. I didn't realize that. So you could have an abstract class extend a non-abstract class, which is kind of advanced, but not our purpose here, right? So let me continue with my train of thought. So if you have a gasoline car extends a car, when I do that, naturally you can see the function generate for me. It says, okay, you are extending an abstract class called car, and the car has the ability to go. But that ability right now is abstract. It hasn't been instantiated yet. But now you are defining a non-abstract class, that's a gasoline car, meaning that every method in this class should be non-abstract. And because I extend car, my gasoline car has all the functions from my car. Let me do this. Okay, so my gasoline car has all the functions from my car. And it should therefore be able to call those functions. And because it's non-abstract, those functions shouldn't be abstract. And right now, in car class, Go is abstract. So the only way to make it non-abstract now is to override it in my subclass, gasoline car. Okay, so let me make another example, because we just found out that. Let me say I make an electric car. That extends my car object. And let's say I want my electric car to be abstract to begin with. Okay? And this would be okay. Okay? But this is not. Okay, you see an error here. It says gasoline car must implement the inherited abstract methods. Okay, you must have this. I must implement that. However, for electric car, it's okay, because electric car itself is abstract. So that means abstract methods can exist inside it. Okay. For our purpose here, let's not do that. Let's say we want to add our implement method here as well. So a gasoline car will have its, say, it can have its own fields. Let's say, for example, we can create a integer representing, or a let's do integer. It's better to do double. Let's double our remaining gas. Okay, in the number of gallons. And for electric car, I would say it's our remaining. I don't know what's let's call remaining power. I don't know much about electric car. Okay, so and we can in each of their method. Okay, we can write something here. So here, let's say system out print, and let's print a line saying that gas car go. And similarly, in our electric car, we can do something like that, saying electric car go. Okay. And then in our demo, let's try to use this class. Okay, let's create. First of all, we cannot create a car that's abstract. We can't do that. However, we could do electric car. Okay, ED car, ED car. Let's do a new electric car, and we can now do electric car go. And let's run this. So we see our output here, electric car go. Similarly, we can do our gasoline car, gas car, new gasoline car. All right, gas car go. Okay, so that works. Okay. Now this is simple enough. This is simple enough. But in Java, okay, in Java, there's a few things to note. First of all, in Java, every single field is strong typed, right? For example, I call this electric car. I call this electric car, and I say this electric car is of type electric car. That means it must be of type electric car. So if I create a gasoline car here, right, it's going to say, throw me an error. And if I try to run it, even if I know that there's an error, it's going to say, oh, you created a gasoline car here, but we cannot convert a gasoline car to an electric car. So you cannot do that. However, there is one instance we can do it. Here, I modified here this used to be electric car, right? If I replace that with a car type, I'm saying that, okay, I'm going to create a variable called in car, and it has a type car. I'm going to create a variable gas car and it has a type car. Right? When I do that, what happens? Let's see. This is okay. Everything is fine. Because I create an electric car, I assign that to my edit car. And my edit car is of type car. If it's a type car, that means it can be either a car or anything under it, right? For example, if I say there is a bird called Peter, right? Let's say I create a bird called Peter, right? This bird can be a penguin, it can be a kangaroo, not kangaroo, sorry, kangaroo is not bird. It can be a flamingo, it can be a woodpecker, right? So you could do anything here, right? It could be a woodpecker, it could be a pelican, right? You could do any of those, right? Imagine we have those classes. And here this shows the power of inheritance, right? For example, you want to create an object like a employee, a person. Every person can have a car, and you don't need to know the type of the car to begin with. You can just claim that, oh, there will be a car 1, there will be a car 2, and you don't care if car 1, car 2 is electric car or gas car, right? As long as it's one of those cars. As long as it's one of those cars, it should have a method called go. And if it has a method go, you can call the go on it without knowing what's the actual class. So that actually relates to the 2 goals in object-oriented programming, right? In our slides, you can see that we want to be writing robust programs. We want to write programs that can adapt. Like here, by doing this, right, you are writing robust programs. Okay. Now, another thing I want to mention real quick is that there is something called interface. Okay, let me create an interface for you. Let's say this is a car interface. Right? Interface is very similar to abstract class. Very similar. Except that you cannot have field in it. Say year. This is not okay. Right? You can have like constant, public static final. You can have this. Right, you can have this, which is a constant to interface. For example, let's say the cars are invented in I don't know when it was invented. It's 1930. I'm just making up things. Probably not that. Probably earlier than that. You can have constant values here, but you can never have individual variables like what we have here. So this value here is a static value. So that means it's shared by everything that uses the car interface. So all the car will know that the cars are invented in 1930s. Okay, it's also final, meaning that it's constant, it doesn't change. Okay, so that's just something you should know. Interface and abstract class. I would say abstract class is more widely used because it has these additional abilities. And it's also possible to declare the same things inside the abstract class over here. So this is fine, right? So interface is slightly more limited, and people use it for that reason, so that they know that when you are building a function inside an interface. By the way, don't think it allows this. Yeah, it doesn't allow that. So let me try this. Return some string. Okay, this is not allowed. It has to be static. So interface is slightly different. Interface is like declaring static things shared for the whole class, for the whole interface. Right? We will not get into this for now. Okay, let me delete my interface class. All right. So another thing I want to mention in inheritance is that when you define a subclass for a superclass, not only can you override the existing method, for example, in my gas car, for example, I override my function go, which is an abstract class. I must override it. I can also choose to override other functions. Let's say I want to override public void turn on engine, right? This is also doable. And I can say, okay, I'm still going to turn on the engine, but now because it's a gasoline car, it's going to go boom, boom, boom. Okay, so print 9, I will go boom. Right. Now here, we notice an issue with the mistake I made. Previously, I defined the engine on as a private value. So private, if we remember, private means it's only accessible to the class itself or under the same file. Okay, let me double check that. Okay, so I double checked. Private means that a variable is only accessible within the declared class. Okay, so it can only be seen within this scope. So engine on is not available for gasoline car. Now, to fix this, you can change the private to protected. Now, if it's protected, it's going to be inherited by its children. You can also make it public, which will also be inherited by its children. But I think protected is fine. Okay. So now, once I make engine on protected, I can access that value from my car, gasoline car. Okay. And another thing I want to mention is about the inheritance of constructor. All right. Let's quickly check something. So let's say we have a constructor here, right? Let's make a constructor public car, right? And we are going to make up some things like our make is, let me say make, right? Model is model in string format, and the year is 1930. Okay, all right. So we have a constructor here, right? And let's run our demo over here and see what happens, right? And let's say let's look at our make. Make is actually make. Amazing, huh? So normally, like if I don't have this, okay, if I don't have this, that means my superclass don't have a constructor. So there will be a default one, and the default one is just going to give the default value. So string will be, I think, either null or empty. The number will be just 0, right? So you have the default value, and if I inherit that, in my electric car and the gasoline car. That means if we try this again, you will see the make is null. Okay, but however, when I change my default car, the superclass default constructor, it actually influenced the default behavior of my subclass. Now, why is that? This is because inside gasoline, right? Inside gasoline, the gasoline car constructor, actually its default behavior does this. Okay, it calls super, which is the constructor of its superclass. By default, it does that. All right. So, for example, let me remove this. Right. Let's not do that. Let's make it be empty. For electric car, let's not touch it. Okay. And then let's try this. We have an electric car. Let's print out the make for the electric car. We have a gasoline car. Let's print out the make for the gasoline car. And we print. Oh, wow. See, even if I do that. So first of all, for electric car, it's using the default behavior, which is calling the car itself, right? For gasoline car, even if I don't call super here, the super is still called. And that means what happens is that when you call the constructor of a subclass, when you try to create an object that's a subclass, it actually calls the constructor of the superclass first, and then calls the constructor of the subclass. So even if I don't call the car inside in my gasoline car, it actually gets called beforehand, right? When it creates the object. Okay, so this is kind of confusing. I didn't remember this either. I saw on a book. Now, what if I don't want it to be make, right? What you can do is that you can write your own default behavior. You can say, okay, the make should be null, the model should be null, and the gasoline cars are numbers should be 0. Okay, and once again, I should change this to protected so that my program can work, right? Because they can, otherwise they can only be accessed within car. Okay, so I'm getting into a lot of details here, but I think those are like the fine details that if you understand class inheritance well, these details are actually very interesting. All right, I'm not repeating the books. Okay, so if I do this, right, electric car still have the default constructor, gasoline car has a special constructor. And know that when I create my gasoline car, the car constructor, the superclass constructor, gets called anyway beforehand. Okay, let's see what happens if I run it now. The electric car still has a model of make, which is built here. But the gasoline car now have a model of now, right? This is because even though the superclass constructor is called, it fills in the field. It fills the values, make, model, year with those values. But when I call my gasoline car, the values gets overwritten by my new values. Okay, so that's one thing that's interesting, right? This is the order of constructor being called, right? And let's say what other thing you can do is that you can also implement additional functions. For example, a gasoline car can refill gas, right? A gasoline car has a gas tank. Let's copy this over here. A gasoline car has a protected remaining fuel. Okay. And when I refill my gas, I can increase my remaining fuel by a certain amount. Okay. Right, I can do that. So this is a function that's not visible, that's not inside car. But because I extend car, I can have more stuff. And in my electric car, sorry, I have the remaining gas here. Let me take that away. In my electric car, I can also have a function myself that's called recharge. Let's say void recharge. And let's put double here. This is the charge I want to put in my remaining charge. Okay. All right. So one minor detail I want to highlight here is that here I said that this remaining fuel. Here I didn't say this, but this is like assumed, right? Assume that the Java program assumed that there's this here. I don't need to write it here. However, okay, imagine say you have a few functions here, right? A few variables here, and one of the variables happen to have the same name, remaining power, right? And now it becomes a problem because you have a field in your object that has remaining power. You have a input parameter in your function that has also remaining power. They're the same name. So to differentiate that, you can add a this here, right? So by adding a this, you know for sure that this remaining power is the field value in this object. Okay. And the even better practice is to use this and also try not to have a name conflict. Okay, this is the best practice. Use this and also try not to have a name conflict. Right, so now we have that. I'm going to have that. And okay, so let's try this. Car 1, can I refill my gas? It's an electric car, sorry. So can I recharge? Let's say recharge. Let's say 5 minutes. Okay. Gives me an error because car 1 is still an abstract class car, right? It doesn't know that it's no longer abstract. So the only way to call recharge is that we know for sure this car 1 is an electric car. So to do that, you can do this. You can first convert that to an electric car, right? I first convert to an electric car, and then I say, okay, now this whole thing is an electric car. I can now recharge. And this is okay if I run the program, right? Same thing for my gasoline car. So gasoline car 2, and refill gas here, 5.0, right? If I do that, oh, I need a dot here, sorry. And this is okay. Now, if I want to break it, let's say I want to convert my car 2 to an electric car, and I want to have a recharge. Now, what do you think is going to happen? There is no compiler error here, right? Because a car 1 is a car, and a car can potentially be an electric car. It can potentially be a gasoline car. Here, I don't know what car 2 is, but let's try to convert it to an electric car. And if I run this, I get an error because the object under this car 2, which is referenced by car 2, is actually a gasoline car. It cannot be converted to an electric car. Right, so I get an error. So this has to be a gasoline car. And a gasoline car can only refill gas. Okay. All right, I think that's enough for today's lecture video. For the homework, you can after you watch this, for the next time, you can go over the slides, and I think the most important thing is to pay attention to what generic is. All right, the last 3 slides, generic. Okay, what they are. Right, those are also an advanced topic in Java, and I assume that you should be getting some of it in your previous class. But we can go over this again.